Hello students, welcome to Yupp Master. This is 11th class IIT English Live. I am Radha Krishna, mathematics teacher. We are going to continue our third lecture in theory of equations. Today we are going to discuss some applications of calculus and graph of a cubic polynomial and then transformation of roots of a general equation, general nth degree equation. Okay. Let us start. First of all, the graph of a cubic polynomial. The general shape of the graph of a cubic polynomial will be like this. This is the general shape. Okay. Then these two are two positions, and let us see other positions. See, the graph can be like this, but its position can be like this or like this or like this or like this or like this. How to know the position of the graph exactly? See, in the first situation, the graph intersects the x-axis at three distinct points. In the second situation, the graph intersects the x-axis at only one point. And in the third case, the graph intersects the x-axis at only one point. Again, in this case, the graph intersects the x-axis at one point and touches the x-axis at one point. And here also the graph touches the x-axis at one point and again intersects the x-axis at another point. Now, to know the position of the graph exactly, we have to use calculus. Okay. Now, in this situation, when the graph intersects the x-axis at these 3 points, y will be 0. Okay. If y is 0, then this cubic equation will have 3 distinct real roots. In this situation, the graph intersects the x-axis at only one point. So, only one root of this cubic equation is real. But what about the remaining 2? There will be imaginary or non-real complex numbers. And in this case, the graph intersects the x-axis at only one point. So, it will have, the equation will have, cubic equation will have only one real root and the remaining 2 roots are non-real or we can say imaginary. In this case, what happens? See, here if these 2 points coincide, then the graph will be coming like this. Is it not? If these 2 points coincide, then we will get this case. So, in this case what happens? All 3 roots are real, but these 2 roots are equal. Out of the 3 real roots, 2 are equal. Okay. And in this case also, the graph, the cubic equation will have 3 real roots in which 2 of them are equal to each other. Okay. Now, let us discuss how to know the exact position of the graph so that we can identify the number of exact number of real roots of the equation. Okay. Now, let us take f of x is equal to the cubic polynomial ax cube plus bx square plus cx plus d. This cubic polynomial is denoted by f of x, and its graph will be in the shapes like this or like this only when a is positive. When a is positive, the graph starts at minus infinity and it increases, it attains a maximum value at some point, then from there it decreases and attains a minimum value at some point, and from there it increases till infinity. So, totally this cubic polynomial varies from minus infinity to plus infinity, but in between it increases, reaches a maximum, decreases, reaches a minimum, then increases till infinity. In all the cases, increases, reaches the maximum, then decreases, reaches the minimum, then increases. See, in all the cases it is moving like that only. But when a is negative, the graph will be like this. First decreases, then attains a minimum value, then increases, attains a maximum value, then again decreases till minus infinity. So overall the value of the the cubic expression varies from minus infinity to plus infinity in this case also. Similarly here graph decreases, then increases, then decreases. So here it is said to be minimum, here it is said to be maximum, and again in different positions when a is less than 0. When a is less than 0, graph starts at infinity, decreases, attains a minimum, increases, attains a maximum, then decreases. This is the general shape when a is negative. Okay. So whether a is greater than 0 or less than 0, we can notice that it attains a maximum value and minimum value. When a is negative, then first it attains minimum value, then maximum value if a is negative. If a is positive, then first it attains maximum value, then minimum value. Okay. Now you must have studied differentiation in physics and a few simple applications of differentiation. Whenever a function attains a maximum value, at this point tangent will be parallel to x-axis, then and the slope of the tangent is given by dy by dx. If the tangent is parallel to x-axis, then dy by dx at this point will be 0. Similarly, if a function attains a minimum value at some point, there if you draw a tangent, the tangent will be parallel to x-axis. So dy by dx will be 0. So in our graphs, when the function attains maximum value or minimum value, see at this point and this point, tangents will be parallel to x-axis. So dy by dx or f dash x, derivative is denoted by dy by dx or f dash x, will be 0 at these 2 points, is it not? So in order to identify where it will attain maximum value and minimum value, we have to find dy by dx and equate it to 0 and find the values of x. So I will find dy by dx or f dash x. You will get 3ax square. I hope all of you know simple differentiation. Derivative of x power n is nx power n minus 1. Derivative of constant is 0. Derivative of ax cube is 3ax square plus derivative of bx square is 2bx plus derivative of cx is c, derivative of t is 0. Now if f dash x is equal to 0, then this quadratic equation is 0. This quadratic expression is 0. Then this equation may have two distinct real roots, may have equal roots, or may have imaginary roots. First I am taking the case when the roots are real and distinct. Let alpha and beta be the distinct real roots of the equation f dash x is equal to 0. When will you have distinct real roots? When the discriminant is greater than 0. Then when it has two distinct real roots alpha and beta, let alpha be less than beta, alpha be the smaller root. Then at these 2 points at x is equal to alpha and x is equal to beta, the slope of the tangent of f of x is 0. Then as we discussed, it should have maximum value or minimum value. Now if you look at these graphs, when a is positive, it will have maximum value at alpha, smaller root, minimum value at beta in all the cases. This is alpha, this is beta. Okay, this is alpha, this point is beta, this x coordinate is alpha, this x coordinate is beta. Okay, and in case a is negative, then if a is negative, then what will be the shape? Like this. First it attains minimum value, then maximum value. Then at the smaller root alpha, it attains minimum value. At the larger root beta, it attains maximum value. Here also. First it attains minimum at alpha and maximum at beta. Okay. In all these cases. Now let us come to the actual point. When the graph is like this, you can notice that maximum value is above the x-axis, maximum point is above the x-axis, minimum point is below the x-axis. What does it mean? F of alpha, the value of the function is maximum at x is equal to alpha, but what is the actual maximum value? It is substituting x is equal to alpha there, we will get f of alpha. If you take this as f of x, this quadratic, this expression as f of x, then this maximum value is f of alpha, and at x is equal to beta, the value of the function is f of beta. In this situation, you can clearly notice that f of alpha is positive, f of beta is negative. What does it mean? The graph cuts the x-axis at 3 distinct points, then you will get 3 distinct real roots. In this case, f of alpha is positive, f of beta is also positive. Both maximum and minimum are above the x-axis only. Then the graph is like this, then clearly it intersects the x-axis at only one point. So only one root is real and 2 roots are non-real or complex numbers. And if you take next case, here f of alpha is negative, f of beta is also negative. Then the graph intersects the x-axis at one point only. That means there is only one real root and 2 non-real roots. In this case, f of alpha is positive, but f of beta is 0, because beta lies on x-axis. The minimum point lies on x-axis. So the value of the minimum is f of beta is equal to 0. So what happens here, as we discussed earlier, we can say that graph cuts the x-axis at 3 points, but out of 3 points, 2 coincide. That means this cubic equation will have 3 real roots in which 2 are equal. Similarly, here f of alpha is equal to 0 and f of beta is negative. In this case also, we say that graph intersects the x-axis at 3 points, but 2 points coincide. So this equation f of x is equal to 0 will have, cubic equation will have 3 real roots in which 2 are equal. Next, coming to this case when a is less than 0, here f of alpha is negative, f of beta is positive. So minimum point and maximum point are on either sides of x-axis. In this case, graph intersects the x-axis at 3 distinct points. And if you take this case, both f of alpha and f of beta are positive, then the graph is intersecting the x-axis at one real point only. Next, here both minimum and maximum are negative. F of alpha and f of beta both are negative. So graph intersects the x-axis at one point only. Here minimum is 0, maximum is positive. Therefore, the graph intersects the x-axis at 3 points, but 2 points are coinciding. So cubic equation will have 3 real roots in which 2 are equal. Similarly here also. So let us write the conclusions. Let f of x is equal to ax cube plus bx square plus cx plus d and alpha and beta be the distinct real roots of f dash x is equal to 0. We know that f dash x is equal to 0 is a quadratic equation if its real roots are alpha and beta, where alpha is less than beta. Then if f of alpha into f of beta is negative, if the product of the maximum and minimum values is negative, what does it mean? If maximum is positive, minimum is negative. If maximum is negative, minimum is positive. That means maximum point and minimum point are on opposite sides of the x-axis. Is it not? So whatever be the value of a, positive or negative, if the maximum and minimum lie on opposite sides of the x-axis, then the graph, suppose a is positive, it should be like this. If a is negative, it will be like this. Minimum is negative, maximum is positive. So whenever maximum and minimum values have opposite signs, or when the product is negative, then the equation, the cubic equation f of x is equal to 0 will have 3 distinct real roots. Next point, suppose f of alpha into f of beta is positive. What does it mean? F of alpha and f of beta have same sign, either both are positive or both are negative. If both are positive, suppose a is coefficient of x cube is positive, then the graph will be like this. If both are negative and a is positive, graph will be like this, when f of alpha, f of beta both are negative. Similarly, when a is negative, graph starts here. If both f of alpha and f of beta are positive, graph will be like this. If both are negative, the graph will be like this. Then in all these cases, graph intersects the x-axis at one point only. So the equation f of x is equal to 0 will have one real and two non-real complex roots. Okay. Next, if f of alpha into f of beta is equal to 0, then one of them should be 0. Either minimum value or maximum value is 0. So the graph touches the x-axis like this. Suppose minimum value is 0. In this case, what will you say? F of x is equal to 0 will have 3 real roots in which 2 are equal, if maximum value or minimum value is equal to 0. So these are the different conditions for different positions of the graph, so that you can know the exact number of real roots of the cubic equation. But this is only one case, when the equation f dash x is equal to 0 has 2 distinct real roots. What is f of x? Ax cube plus bx square plus cx plus d. F dash x is 3ax square plus 2bx plus c. If f dash x is equal to 0 has 2 distinct real roots, then the graph will have maximum point, minimum point. We have already discussed all the cases. Now, if f dash x is equal to 0 has 2 equal roots, real but 2 equal roots, then what happens? When the roots are real and distinct, graph bends like this, attains maximum and minimum. When these two coincide, you can easily visualize the graph. When this point, maximum point, minimum point coincide, then the graph will be like this. This point, suppose this is alpha, this is beta, those two coincide, then the coinciding point will come to this position. Then you can see that the graph can intersect the x-axis at one point only. So, if the roots of f dash x is equal to 0 are real and equal, then the equation f of x is equal to 0 will have only one real root. Okay, two roots are imaginary or non-real complex numbers. Next case is if f dash x is equal to 0 has imaginary roots. If it has imaginary roots, what is the condition for imaginary roots? Discriminant is negative. In quadratic expressions, we have discussed so many points. When the discriminant is negative, the quadratic expression and coefficient of x square will have same sign. Okay. If delta is less than 0, then 3ax square plus 2bx plus c is greater than 0 for all x or less than 0 for all x. Okay. When will this happen? When a is positive, and it will be less than 0 for all x when a is negative. That means f dash x is equal to 0 has no real roots, means there is no maximum point, no minimum point. In the previous case, maximum, when delta is equal to 0, maximum point and minimum point coincide. But here no maximum, no minimum. In that case, the graph will not bend, it will be completely increasing. When a is positive, the graph will be like this. When a is negative, it will be completely decreasing. So, what can you say about the roots of f of x is equal to 0? Graph can intersect the x-axis at one point only for any value of a. So, in this case also, the equation, cubic equation f of x is equal to 0 will have only one real and two non-real roots. So, let us see, if f dash x is positive for all x or negative for all x, when can it happen? When a quadratic expression is greater than 0 for all x or less than 0 for all x, it can happen only when discriminant is negative. When the discriminant of f dash x is negative, then the equation f of x is equal to 0 will have one real and two non-real roots. Let us solve some problems on the points discussed so far about finding the number of real roots of a cubic equation. First question, find the number of real roots of the equation 2x cube minus 3x square minus 12x plus 6 is equal to 0. So, let us take the cubic expression as f of x. F of x is equal to 2x cube minus 3x square minus 12x plus 6, right. Now, what should you find? F dash x. F dash x is equal to 6x square minus 6x, all of you know differentiation, derivative of x cube is 3x square, derivative of 2x cube is 6x square, derivative of minus 3x square is minus 6x, derivative of minus 12x is minus 12 plus derivative of 6 is 0. Now, we got f dash x. If it is equal to 0, we should check whether the roots are real or imaginary. If it has imaginary, then it has no maximum minimum points, so it will be entirely increasing or entirely decreasing, then the graph can intersect the x-axis at one point only. So, directly we can say that number of real roots is 1. Now, if there are two distinct real roots, then there will be a maximum point and minimum point. Then we have to check whether they are on a same side of x axis or opposite sides of x axis. Now, let us cancel 6. This equation becomes x square minus x minus 2 is equal to 0. You know how to factorize it. The factors are x plus 1 into x minus 2. If it is equal to 0, x is either minus 1 or 2. So, there are maximum minimum points. When x cube coefficient is positive, then at smaller root it will have maximum value, at larger root it will have a minimum value, is it not? So, let us take x axis and y axis. Take minus 1 here, 2 here, and when x cube coefficient is positive, we know the general shape. It increases from minus infinity, it increases, attains maximum, then decreases, attains minimum, then again increases till infinity. But we should know where are exactly the maximum and minimum points. Now, to know whether maximum minimum points are on same side of x axis or opposite sides of x axis, we should find the signs of f of minus 1 and f of 2. If you take the product of the signs, first let us calculate f of minus 1 separately. Substituting minus 1, what are you getting? Minus 2, minus 3, plus 12, plus 6. We do not want its value, we want its sign. Clearly it is positive. Okay. I think it is 13 positive. So, where is the maximum point? At minus 1 it is 13 here. Next, find f of 2 minimum value. Substituting 2, 2 into 2 cube is 16, minus 12, minus 24, plus 6. Clearly it is negative. How much are you getting? Minus 36 plus 22 plus 14. Plus 14 means at 2 it is here. So, what will be the shape of the graph? From minus infinity it increases, reaches how much? 13 maximum value, then decreases and reaches minimum value minus 14, then again increases till infinity. So, what is the number of points of intersection with x axis? Clearly 3. So, number of distinct real roots of this equation is 3. Number of real roots is equal to 3. So, this is how we decide the number of real roots of a cubic equation. Let us take another example. Find the number of real roots of the cubic equation. X cube plus x square plus 5x minus 6 is equal to 0. So, same method. Let us take f of x is equal to x cube plus x square plus 5x minus 6. Find f dash x. F dash x is 3x square plus 2x plus 5. Now, if it is equal to 0, see you can't factorize it, so check the discriminant. Discriminant is b square minus 4ac, 4 minus of 60, it is minus 56, negative. When delta is negative, what can you say? Roots are imaginary. That means there is no maximum point, no minimum point. So, what will be the graph of this function? It will be entirely increasing from minus infinity to plus infinity, is it not? But x cube coefficient is positive, so it starts from minus infinity. But if you want to draw it exactly, find the point where it intersects the y axis. You may not be able to find the intersection with x axis. If you want to find the intersection with x axis, we have to find the real root of this equation. But to find the point of intersection with y axis, you can simply put x is equal to 0. Putting x is equal to 0, how much are you getting? Minus 6. It is strictly increasing, intersects the y axis at minus 6. So, its graph will be like this. No maximum point, no minimum point. So, the number of real roots is only 1, and that real root is clearly positive. You can also tell about the real root whether it is positive or negative, is it not? So, here number of real roots is 1. Right. Next question. Find all values of a for which the equation x cube minus 3x plus a is equal to 0 will have 3 distinct real roots. As usual, we take x cube minus 3x plus a as f of x. Okay. Let us find the roots of f dash x if possible. F dash x is 3x square minus 3. If it is 0, are you getting real roots? Yes, we are getting x square is equal to 1. So, x is equal to plus or minus 1, is it not? So, and x cube coefficient is positive. So, graph starts from minus infinity and attains maximum value at minus 1, minimum value at 1. Okay. Now, if it has 3 distinct real roots, maximum point should be above the x axis, minimum point should be below the x axis. Graph should be like this, is it not? So, what is the necessary condition? F of minus 1 should be positive and f of 1 should be negative. What is f of minus 1? Minus 1 plus 3 plus a should be positive. So, we will get a is greater than minus 2 and f of 1 should be negative. What is f of 1? Substituting 1, x is equal to 1, 1 minus 3 plus a should be less than 0. So, a is less than 2. Both the conditions must be satisfied. If a is greater than minus 2 and a is less than 2, then answer is a belongs to open interval minus 2 to plus 2. If a lies in this interval, this cubic equation will have 3 distinct real roots, right. Now, we are going to discuss transformation of, 1 minute, discriminant of a cubic equation. What is discriminant of a cubic equation? All of you are aware of discriminant of a quadratic equation, and using the discriminant we can decide the nature of the roots of a quadratic equation. Now, if you take a cubic equation in this form, x cube plus ax plus b is equal to 0, then 4a cube plus 27b square is denoted by delta. It is called discriminant. And you, based on the value of the discriminant, we can tell about the number of real roots. Okay, let us see how. First, let us take f of x is equal to x cube plus ax plus b. X cube coefficient is positive, so graph starts from minus infinity, increases, then it may attain maximum value, then minimum value, then infinity, or it may be entirely increasing also. Find f dash x. 3x square plus a. If a is positive, then f dash x is equal to 0 will have no real roots. Then the graph is strictly increasing. Is it not? In this case, f of x is equal to 0 will have only one real root. That means remaining two are imaginary. Now, if a is negative, then this quadratic equation 3x square plus a is equal to 0 will have real roots. 3x square is equal to minus a. We get x is equal to plus or minus root minus a by 3. Okay. Now, at these two roots, f dash x is 0. So, at smaller root, f of x will attain maximum value, at larger root it will attain minimum value. For our convenience, let us denote them by plus or minus alpha. Alpha means root over minus a by 3. Now, f of x is x cube plus ax plus b. It attains maximum value and minimum value at alpha and minus alpha and plus alpha. So, I am taking minus alpha here, plus alpha here. If f of x is equal to 0 has three distinct real roots, maximum point should be above the x axis, minimum point should be below the x axis. Graph should be like this. What is the condition? F of minus alpha into f of alpha should be less than 0. Is it not? For this case, let us simplify this. F of minus alpha is minus alpha cube minus a alpha plus b into f of alpha is alpha cube plus a alpha plus b less than 0. Multiplying these two, see these two are in the form of a plus b into a minus b. Multiplying them, we will get b square minus of alpha cube plus a alpha whole square less than 0. Take alpha common from these two, b square minus, if alpha comes out, it becomes alpha square into, inside we get alpha square plus a whole square less than 0. What is alpha square? See here, we took alpha as root over minus a by 3. So, alpha square is minus a by 3. Substitute here. B square minus of minus a by 3 plus a by 3 into minus a by 3 plus a whole square less than 0. Then we can write as b square plus 4 a cube by 27 less than 0. Multiplying by 27, we get 4a cube plus 27b square less than 0. And this 4a cube plus 27b square is called discriminant, denoted by delta. So, if delta is less than 0, then all roots are real and distinct, because the graph will be like this. Suppose delta is equal to 0. Delta is equal to 0 means f of minus alpha and f of alpha is 0. So, either minimum point is 0 or maximum point is 0. Then the graph touches the x-axis. In that case, there will be 3 real roots, but 2 are equal. So, if delta is equal to 0, then all roots are real in which 2 are equal. Next, if delta is positive, what happens? F of minus alpha and f of alpha is positive. That means maximum point and minimum point will be on the same side of x-axis. Then both the roots are, 2 roots are imaginary, only 1 root is real. If delta is greater than 0, only 1 root is real, 2 are non-real. That means cubic equation always has a real root, at least 1 real root. Is it not? Not only cubic polynomial, if you take any polynomial equation of odd degree, it will have at least 1 real root, because odd degree polynomial varies from minus infinity to plus infinity or plus infinity to minus infinity. So, graph will definitely intersect the x-axis at least 1 point. So, this is called discriminant. If you want, you can solve problems by using the discriminant. Let us take one example. Find the number of real roots of this equation. But one more thing, we can use discriminant only when x square term is absent. In the cubic equation, only when x square term is absent, we can use the discriminant and tell the number of real roots. Now, in this equation, it should be in the form of x cube plus ax plus b is equal to 0. So, divide by 2. Dividing by 2, x cube plus 3 by 2x minus 2 is equal to 0. What is delta? 4a cube plus 27b square. Calculate 4 into a cube is 27 by 8 plus 27 into b square is 4. Clearly it is positive. So, number of real roots is only 1. Only 1 real root, 2 non-real roots. Okay. Now, we are going to discuss transformation of roots. Already we have done many problems in transformation of roots in quadratic equations. The approach, method, everything is same. Suppose f of x is equal to 0 is a polynomial equation of any degree. Its roots are alpha, beta, gamma and so on, depending on the degree. Suppose a constant k is added to every root. What did we discuss in quadratic equation? If a constant k is added to every root, then the transformed equation can be obtained by replacing x by x minus k. How? You take alpha plus k as y, then alpha will be k minus y minus k. Alpha satisfies this equation, that means replacing x by y minus k, f of y minus k will be 0, and this equation will have roots alpha plus k, beta plus k, gamma plus k and so on, but final answer should be written in terms of x. That is why the transformed equation will be f of x minus k is equal to 0. Similarly, if a constant k is subtracted from every root, then we have to replace x by x plus k to get the transformed equation. And suppose every root is multiplied by k, then we should divide x by k, means you have to replace x by k to get the transformed equation. We have discussed all these things in quadratic equation. So let us start the problems directly. Find the equation whose roots are the reciprocals of the roots of this equation. It is a fourth degree equation. It will have 4 roots, maybe real or imaginary. Let alpha, beta, gamma, delta be the roots. Now we want the equation whose roots are reciprocals of these 4. So take reciprocal of one of them as y. Then calculate the old root. Old root alpha is equal to 1 by y. It will satisfy the given equation. So replacing x by 1 by y, 1 by y power 4 minus 2 by y cube plus 3 by y square minus 4 by y plus 5 is equal to 0. Multiplying by y power 4, 1 minus 2y plus 3y square minus 4y cube plus 5y power 4 is equal to 0. This is the fourth degree equation whose roots are 1 by alpha, 1 by beta, 1 by gamma, 1 by delta. But we should write the final answer in terms of x. So let us write it in a standard form. So highest degree is to lowest degree. 5 x power 4 minus 4x cube, replacing y by x, plus 3x square minus 2x plus 1. This is the equation whose roots are reciprocals of the roots of this equation. So you can simply remember the method that if the roots are made reciprocals, write the same equation by interchanging the by writing the coefficients from right to left. So last coefficient becomes first coefficient, second last becomes second coefficient. In this way, if you reverse the coefficients, order of the coefficients, you will get the new equation, right? Next question. If alpha, beta, gamma are the roots of this cubic equation, find the equation whose roots are 2 alpha minus 1, 2 beta minus 1, 2 gamma minus 1. Take one of the new roots as y. Then calculate the old root. Old root means alpha. What is alpha? Y plus 1 by 2. 2 alpha is equal to y plus 1. Alpha is equal to y plus 1 by 2. This alpha should satisfy the given equation. So I will substitute. So let me substitute y plus 1 by 2 in the given equation. Then simplify. Before simplifying, multiply by 2 cube, 8. At the same time, expand whole cube, whole square. Expansion of y plus 1 whole cube is y cube plus 3y square plus 3y plus 1. Multiplying by 8, this 8 will 2 cube will cancel. Here y plus 1 whole square is y square plus 2y plus 1. Multiplying by 8, 2 square will cancel, another 2 will multiply. Here this 2 cancels, multiplying by 8, we get plus 8y plus 8 minus 3 is equal to 0. Now write the equation in the standard form. First y cube term, only one y cube is there. Next y square term, 3y square minus 2y square, so plus y square. Next coefficient of y, here 3y minus 4y plus 8y. 3y minus 4y means minus 4y minus y plus 8y, minus y plus 8y is plus 7y. Next, constant. Okay, we have to multiply the constant also by 8 now, so this becomes minus 24. Okay, now constant term 1 minus 2, minus 1 plus 8 plus 7, 7 minus 24, it will be minus 17. Now, we have to write the final answer in terms of x. So, the equation whose roots are these three is given by x cube plus x square plus 7x minus 17 is equal to 0. Right. Next question. If each root is diminished by 1, find the transformed equation. Very simple. Already I have explained. If each root is diminished by 1, then we have to replace x by x plus 1. We should add 1 to the variable. So, the new equation is x plus 1 whole cube whole power 4 plus 2 into x plus 1 whole cube minus of x plus 1 plus 3. This is our answer. You can simplify. Next question. If alpha, beta, gamma are the roots of this cubic equation, find the value of alpha plus 1 beta into beta plus 1 into gamma plus 1 by beta plus gamma into gamma plus alpha into alpha plus beta. We can solve this question by using the relations between the roots, also by using transformation of roots. I will explain both the methods. First, write the relations between alpha, beta, gamma. Alpha plus beta plus gamma will be 0 because coefficient of x square is 0. Is it not? Next, alpha beta plus beta gamma plus gamma alpha will be what? 4 by 1, 4. Next, alpha, beta, gamma, product of the roots. Product of the roots is what? Minus 1 by 1, minus 1. Now, we want this product. Simplifying the denominator, beta plus gamma is what? Minus alpha. Gamma plus alpha is minus beta and alpha plus beta is minus gamma. So, you will get alpha plus 1 into beta plus 1 into gamma plus 1 by denominator becomes minus alpha into minus beta into minus gamma. Minus alpha beta gamma. Now, multiply the 3 brackets in the numerator. If you multiply these 3 brackets, you will get alpha beta gamma plus alpha beta plus beta gamma plus gamma alpha. We can write it as sigma alpha beta plus you will get alpha plus beta plus gamma also plus 1 by minus alpha beta gamma. Substitute the values now. Alpha beta gamma is minus 1 plus sigma alpha beta is 4, alpha plus beta plus gamma is 0 plus 1 by minus alpha beta gamma is 1. How much are you getting? 4. Answer is 4. Now, how to solve it using transformation of roots? Let us see. I will write this product as minus of alpha plus 1 by alpha into beta plus 1 by beta into gamma plus 1 by gamma. See, these three are in the same pattern. So, I will find out a cubic equation whose roots are transformed in this manner. So, let alpha plus 1 by alpha, beta plus 1 by beta, gamma plus 1 by gamma be the new roots. Then what will be the transformed equation? We take one of the roots as y. Then calculate alpha. Alpha plus 1 is equal to alpha y. Alpha into y minus 1 is 1. Alpha is 1 by y minus 1. Alpha will satisfy the given equation. Substituting, we get 1 by y minus 1 whole cube, this one, plus 4 into 1 by y minus 1, 4 by y minus 1 plus 1 is equal to 0. Now, multiplying by y minus 1 whole cube, you will get 1 1 plus 4 into y minus 1 whole square plus y minus 1 whole cube is equal to 0. If you expand, you will get a cubic equation. Its roots are these three. Here, without minus sign, we want the product of the roots. How do you get product of the roots? You don't need to expand. Product of the roots is given by minus of constant by y cube coefficient. What is constant here? Minus of constant term 1 here plus 4 here, here minus 1. You can directly tell constant term without actually expanding. By coefficient of y cube in the last expansion will be 1. So, how much are you getting? Minus 4. Product of the roots is minus 4, but the asked product is minus of this. So, what is the value? This value will be 4. We got the same answer. Okay. So, with this, today's class is completed, and we are going to solve many more models in the further classes in theory of equations. Okay. Thanks for watching. See you in the next class.